There's that's the evil ending.
Do you have like the one large cake that goes with your PS5 that Astros?
Oh, actually, yeah, I didn't touch it.
You should touch it. It's good.
Don't say that.
Okay, we can put it like.
I hope they caught that. What? I hope that's the first thing after that. Yeah. My name is Deep. It's an easy one.
Obviously not.
What? So to be fair, everything is also pretty easy. It's actually about 60 hours on the first playthrough.
Also,
Yeah.
one of my birds.
My next Soldier of Godric, the guy from the tutorial, was like the starting armor you get.
Welcome back. Everything was going great. Like we had a nice spring break, but now probably some people are still reeling from yesterday afternoon's. Like UConn's out of March Madness. It was a really good game, but it's pretty disappointing. It was so close. Even a 3, like at the buzzer, you just needed a 6-point shot somehow. But yeah, so we were all rested, and now maybe you're anxious again, or you weren't paying attention. That's okay too. You remember what class this is? Where we are? What are we doing here? Well, module 3, applied mechanics number 2, and module 3 is all like looking at how to build equations of motion when we're talking about like constraints and like F equals ma. So rather than just simple a force is applied and constant acceleration, what happens when things have to move in a certain way, but there's still like free motion. There's degrees of freedom. Yeah, so that's where we're at. And a while ago, this was before spring break, we were looking at like first question, talking about vectors again, because everything's going to be like vectors equals vectors. So the sum of the forces is our ma term, and that's going to determine our equations of motion. And we went through some stuff, looking at those. But now we're at like 3.2 and 3.3. So I'll grab this one. Let's do a new page. Okay, so we have these three forces acting, kind of a weird third force, like 5 minus 4 root 6 EY, but that's all right. But it's acting, we have these three forces acting on one point, and it's not going to move. Or it has a constant velocity, either way. But somehow acceleration is 0. There's no net force. So we want to figure out what is the angle of force number 2 so that all the forces are 0. So ma equals 0. Just 0 and 0 for if we're thinking about like two-dimensional kind of stuff. That's what we're solving for this kind of point. Just jumping right back in. Right where we left off, right? Like nothing changed. So I want to see like how you start this, like what's your first step that you're thinking here?
You can Okay, yeah, I just. I didn't think of this.
How you change it?
Jumping into
Why?
regions.
That's basic. Yeah, but you could do that one. You don't need to be. You should have.
It was even worse before I was
Okay, buddy.
and then this already. This doesn't count.
Oh, it's just your anyway.
Yeah, so that's
So
basically
those are your
it's
Is a direction that's not to
it's like a light.
It's just.
I know that.
That's just like.
And then I didn't say
I really, you could just put stuff out. It's just a
I want to
bit.
see in reference when I coffee jumping.
Yes. It's in the game. Actually, it's not.
Okay.
I would be proud of that.
Oh, I did that. I did that.
I couldn't get 3130. I have to do it.
I just searched for some classes like manually. Luckily, I got it approved to do a break as well. I'm really surprised.
You gotta squeeze in lunch a week.
I mean, you can buy sandwiches from it.
Because why would you look at I cannot find anything. I learned where I like to take it during the anything in there. And I said, screenshot the text, so I'm not having that.
F3.
And she said,
Oh, that's a good question. Wait, what do you mean?
I don't know what that was. Yeah.
Okay, as for
I don't know what that is. Yeah. Honestly, they're the same. I just did for you just pick you take your classes and then pick which one you want. Oh, really?
So it's a negative.
Mine just has 4 built in, which I think makes more sense.
Aren't you all? I think they're trying.
Yeah, I want to different title.
Yeah.
They transferred out. So it makes it easier. Some of the classes I take.
I actually I think three electives.
And I also but yeah, it was really nice.
Yeah.
So it's
Because I'm taking some environmental science class right now. That's where I'm I need one more.
it was not hard, so I guess that's yeah.
That's probably good.
Yeah. But my friend actually said.
Yeah, you need like one more answer.
I did like after.
No, I think
That's scary. Honestly.
maybe it is.
I don't know if I have that.
Yeah, components is probably.
How could it be zero? It has to be.
Yeah.
Because the online schedule planner, for me, it said I needed like 5 3,000 local classes, but on the paper copy of the planner, it said I needed like 3,000 local classes. Yeah, that's
They do change.
I will do it if it's
Well, no, it's not like it's not an it's like you put it under that yeah, but like
every other course is a whole nother. And it could have been easy if they made courses. If they were like 25 grades, so in the physical 5 grades.
so it's not like but last year I did
F1 now,
Okay, jumping right in. I think I saw most people that were kind of getting started just trying to math their way through it of like fx equals 0, fy equals 0. I know all the components. Let me just plug and chug, figure it out. You want to try that? All right, so we have sum of the forces in the x is 2 plus 10 cosine theta, and then plus 5, oh wait, no, EY has nothing. And then we have a negative 5 plus 10 sine theta plus 5 minus 4 root 6, and all that's equal to 0. Good? So we root 5?
Get rid of the 5.
Oh, get rid of 5. Oh yeah, yeah. Knock that guy out. Cool. So it's done, right? We solved it. So now cosine theta is 1/5, and sine theta is, what is that? Root 6 over 5. Negative 1/5, thanks. Yeah. For 2 root 6, is that right? Did I miss a 2? 2/5 root 6, like that. All right, thanks. Yeah. So we're good. All right. So then, what's theta? Let's find theta. Now we just need like some calculators, right? We can plug it in. You just have to solve these two. Make sure they both satisfy. I guess you could divide them, right? Find tan theta. Say tan theta is something.
I'm in degrees, we work in degrees, leave me alone.
Well, you already have the vector component, because you know the length is 5. Sure, so you have your next
At different angles if you take these inverse, so I don't know what's going on.
So let's see. What would that be?
Because the ranges of the inverse are different. Cosine ranges from
I think like that, right?
yeah.
Tan theta is -2√6.
Like from the other side. If you know where the vector is pointing, the sine is over there, you can't go from the other side.
Something, right, I'm going wrong. No. No, I'm not.
I had the same problem when I was
What? Ah. I wonder why I put it on today.
I'm in the green with over there.
And like after I count that.
Or it's not the same. Because the sine components are in opposite direction, it's going to give you a different place.
Oh, wait. No, yeah, you're right. If I subtract this result from 180, I get this result. Yeah? Yeah! Now, so I got 2 examples. 180 minus 101. Yeah.
101
is negative cosine
Yes.
78.
Are you sure?
Am I doing that math right? Maybe.
So,
So like 94 plus minus 1 that equals
well, I have my research.
Negative 78.46.
yeah.
Degrees, yeah. I'm like 30%. Confidence level?
I just did like sine over cosine. That sine data is 2√6 over. So it's 9. The 5 and the F.
I thought you said we'll round up on Jordan is actually 80. Adam takes something here. I'm proud of that.
Well,
If you round to the nearest relevant degree, it's
yeah, that's for that one.
last night I was up to like 2 a.m. I couldn't fall asleep. Someone left the TV on his sports show, so I'm watching the X-Games. So somebody who's on the snowboard. And I think they like rate how many spins they do. I was like, wow, 90 degrees away from the goal. I was like, wait, that's how that works? So I was thinking, like, if you're a snowboarder, just round from there, like 90 degrees. 91, 83, 60, 7, 20, 10, 80.
Oh, this,
That's simple.
Sure, but now do it.
-78. What else did we get?
101.5.
Anything else?
101.5 minus 70. Or no, 180 minus 101 is the other answer. You know what I mean?
180 minus that?
Thank you. Thank you. No, you're right. They're complementary.
Yeah.
They add 20. If you don't round, those two add 1.
Yeah, 79 plus 101. What else?
But then,
Did we get other answers? There should be at least 2 angles. Like
258.5.
258.5. 258.
oh, wait, it's.
Probably because I'd be going with that's on the other side.
So 101.5. Okay, still negative 10 or 101.5. All right. Did we get other? Did anybody else get a different angle? A couple. Yeah. 70. Oh, positive 78. right, we'll leave the 0.5 in there since we have,
Wait, can't we draw a triangle based on the numbers we have?
Yes.
Like, we have cosine theta, we have sine theta.
Yeah.
We can draw a triangle and definitively know what the right directions are. I know that.
yeah. So this was,
Let's run that.
like, if you do the math first and then try to figure out where it's pointing, it's fine. Like, you can do it that way. Or we could have started with the idea that, all right, I know this, when I say angle is 0, this is where it's pointing. So let's figure out where a non-zero angle is pointing. That's kind of, here we went through a lot of math and we're coming up with multiple answers. And really there's an infinite number of answers, right? Because every pi degree, every 180 degrees is the same tan theta solution. So we need to figure out which one, where it's actually pointing. All right, so let's back up then. What does your free body diagram look like? I'll draw in F3 because I know where that one's pointing. What do F1 and F2 look like? Yeah. Down, which is it going
Positive X, negative Y.
that way or that way? Like down, so down, we know it's going down and then
And positive X.
that way. Okay. All right, now where's F2 pointing? Try drawing, just, yeah, take it, try and drawing it.
It also works if you draw somewhere when you know cosine, if you can use cosine, you know what I'm saying? Now this guy. My best thing. You can just draw it right. You just draw forward and play it. Okay. Adjacent over hypotenuse is -1, so you have backward 1 and 5 is hypotenuse. That means this. And I checked on the calculator. Pythagorean theorem is true. So that this angle is theta.
And then, for data, I got this value, which is using, I use computers. But you just, like, how come you give this other values of data? Like, I understand you can like add what you
Depending on if you use arctan, if you use like inverse tangent or like arctan 2 or inverse sine, inverse cosine, all these values are going to give you like plus or minus pi in the solutions. Yeah. So like if you try.
Because I use tangent, so I just
Yeah.
The question is like where are we drawing this perspective? I guess technically we want this
Okay,
one, right?
And really, like, we can say every pi will give us the same answer.
Okay. And isn't this also like kind of a static problem?
This one's static.
Yeah. Okay.
I'll take it for one. So you guys take it for
Moving, but
Whatever is last.
There was one guy who had like absolute shared views, there's one guy who had less shared. He doesn't teach in that semester. I checked, another person told me that, my buddy, told me, he said, don't take that class, I was not teaching. Pretty bad, that's a teacher.
All right, nice. So with F2, we knew it was going to be, it's got to be pointing away from that resultant of like F1 plus F3. So if we add those two up and make them one vector, F2's got to be opposite that. But the question was trying to figure out like where is theta measured from in this diagram. And again, this is my personal preference, is always use the same angle, at least for these kind of things, unless you have a very good reason to change the angle. I like to always say, this is my angle theta. Like if theta is 0, it's on the x-axis. And if it's not 0, then it's pointing somewhere else. That's my preference. And here this makes sense because if theta is 0, then it's 10 E1 plus 0. Like theta cosine 0 is 1, and then sine 0 is 0. So it makes sense that based on our equations that we have, that is the direction of like angle 0. All right, so now, if that's our angle, do we want, oh, you gotta zoom out a little so you can see it. Do I want negative 78, 101.5, 78, or do I want to add pi to those, or 2 pi, 101, 101.5, right? All right, looking good. Because with a free body diagram, you'll save yourself a lot of trouble of like, especially with sines and cosines, you have an infinite number of answers. Try to narrow it down into why, where is this thing going? When I say it's an angle, what does that actually mean? Where is it pointing? Welcome back. Yeah, moving, right?
And then the guy goes there, he just says alligator. And I love those meters. People just go to this. He has 100 shower notes. That's one thing you hate being back in the Steve, you go with the stroll wind. Stroll wind!
All right. Some more rotating reference frame kind of stuff. All right, so first off, let's figure out what the heck we're actually trying to do. So Cartesian versus polar coordinates. What's the difference in Cartesian and polar? R and theta? Yeah, R and theta. So polar is R and theta. And then Cartesian is I think, therefore I am. Yeah. Like X and Y, yeah. First. So X and Y. So we're going to come up with two different sets of XY components and two different R and theta components. But we're measuring theta and R and X and Y in different ways. So like once we have a vector or a vector, all of our vectors are going to be like some function of time. So this is sort of like a snapshot of, at this point in time, the vector is pointing right there, but it doesn't matter what coordinate frame it's in, like its magnitude direction is always the same. So as we rotate coordinate frames, sometimes the vector rotates with the coordinate frame, other times like the vector might be staying still. So an example is like for this module, we're looking at like pendulums. gravity's always acting like straight down, but our pendulum's like rotating. One way to solve it is a polar coordinate system. So our frame of reference is changing, but gravity stays constant. But anyway, we need to be able to like flip back and forth between different systems. So let's do not that one. So if I want to know what this vector is in coordinate system I, that would be an E1, one E1 component, one E2 component. What does that look like? What is that number? What are those numbers?
Yeah. Okay. Yeah. That's okay.
Oh, this is fine.
What do we think? Like that? 2.3, 3.1? Switch them? All right, thank you. Yeah, nice. That's what, with my kids, that's what I do. I'm like, yeah, alligators climb trees. And like, no, they don't. I'm like, now they're engaged. It's just a little bit of, it works. It works on me. I'm like, that's not right. Like, oh, thanks for joining the conversation. Okay, so we've got coordinate system I. Like, we need to read this graph like it's given, like it's in the information that we had. Like we didn't have to do like trig to get it, but we do have to interpret and label correctly. Bless you. Sorry. So now we're trying to get to the Atlanta Braves. In Atlanta, everything's off by 30 degrees. So now we want to label things with mint juleps in hand. We could rotate. Yeah, what do you want to do? Cosine, sine. Yeah, there's going to be like cosines and sines, right? Somehow. Yeah, so cosines in there, sines in there. And the main thing is rotating by that like 30 degrees, right? So what do you think? How do you want to do that one?
Rotation. Yeah.
I got it. So it would be like 2.3. No, it's not. No, we did the dot product coordination.
You do dot product. Yeah.
That's right. I have to.
Okay.
I don't. Could you possibly recap it for those who might not?
Yeah.
That's for a friend. It's me. We want that product with what we have. So I think you use like two. No, I think the what's it called? I don't think they started. I think
Find the projection along the one. Projection back to the kind of.
Oh, yeah.
That's a nice, like, closed form. One and done.
It always works like some things are like situated. Just fine.
Beta 0 to
Over the magnitude squared times the original vector. Wait, no. Those are your vectors.
Yeah.
Why does that have magnitude?
yeah. So
The
like,
vector of the vector equals times the vector of the vector. But the vector of the vector can go like this, right?
yeah, yeah, you like row, yeah, I like yeah. So it would be like cosine 2 point sine of 3.1, and then negative sine. I think it would be like a cosine.
There was that's
Whenever you have a matrix, take row times.
Yeah, that's
Okay.
I did see you guys. I don't like it. It would be like all of a sudden.
yeah, the rows.
It's different. It's bad.
Oh, so it would be like that. It would be something like you like one.
Chicken jockey. Have you seen what's I feel like the Minecraft will just give you Jack like explaining how Minecraft works.
These villages, chicken roots, skim potatoes.
I don't think they're going to change and break the economy.
The menu village to gauge lockdown.
You build a paper farm.
Yes, exactly.
All right, so it looked like some people were trying to remember or apply like rotation matrix. Is that or dot product? Which one? You want to do a matrix plug in to the matrix or avoid linear algebra? It's only a 2x2 matrix. It's like, I don't know. It's up to you how you want to go. Matrix? Matrix?
I think we just take RPO and
Actually,
dot it with like dot it A1 and A2.
That's only for
So like, if we want to do kind of matrix to get from angle 0 to a non-angle, there's always a rotation matrix that like says, hey, I can rotate this coordinate system by some angle theta. And am I doing that right?
Yeah, because then you can walk.
So I can say that this is like my AX.
The Ronski is non-zero, so Ronski is carrying the whole forever.
So if I'm saying that I'm trying to solve for the value AX and AY, like those are scalar values of my new coordinates, then I say cosine 30, sine 30, negative sine. So now I have like one equation that's solved, one like linear algebra equation. So a set of two equations, but I'm multiplying, saying like cosine 2.3 sine 3.1 is AX. Negative sine 2.3 cosine 30 3.1, that is my AY. Something like that. Like how to do matrix? Oh yeah, I'll walk through that, yeah. Because linear algebra is not a required course. It's really helpful. It's a very helpful course, but if you haven't seen matrices, then you probably don't know how to deal with them. But general process is take the row and multiply it down. So move this way and that way. So AX is going to be row 1 times the vector. AY is row 2 times the vector. Kind of weird, but let's write it out.
Did you evaluate them separately and then multiply them? Didn't you get one?
Like that.
No, it's not.
We are, yeah, it's basically a dot product. It's just showing two dot products at one time. Yeah. Like matrix math is just saying like, okay, here's a whole bunch of dot product stuff, and let me get them separately. So it is the same math. Kind of like that.
You switch, you like go to the right and then you go up. I don't know what I'm talking about now.
And now let's do row 2.
You always go down.
So it's always left to right and top to bottom. Yeah. Kind of it is a helpful skill to know, like, at least how to multiply a matrix, but.
Put it in MATLAB. Put it in MATLAB.
Or you put it in MATLAB. That works.
I don't know how this works in MATLAB.
In MATLAB? Or Python. They're all the same.
How would you do this without the matrix?
Oh, without the matrix? Yeah, we don't have to.
I'm just curious, what's like an intuitive way you could solve this without the matrix? I feel like it's extremely heavy work around.
All right, let's do that. Revisit. Actually, you know what? Let's do this. Isn't there a duplicate? Here, I'm gonna copy this whole thing down. All right, so we did some matrix math, but we don't have to.
So that's all right. Intuitive, non-trivial.
Yeah. So another way that we could say this is I think this is what we did last time, was think about like this 2.3 is the projection of that vector onto the x-axis. So if we take that, if we're on the x-axis looking at that vector, we can only see like 2.3 of it. And on the y-axis, we can see 3.1. And that's projecting it onto it, so a dot product of the vector onto that axis. We can do the same thing along the A1 axis, just kind of rotate by 30 degrees and say, what is that vector on that A1 axis? So if we know what A1 is, so A1, I know that it's pointing at 30 degrees off of that E1 axis. So it'll be like a cosine 30 along E1. And then how much along that E2? Cosine 30, E2? No? Sine 30? Like that. So now I can set up an equation that AX, again, like that scalar value, like how much of that vector is on my A1 along my A1 direction, unit vector, is RPO dotted with A1, or can't write. I'm just running out of room. So C and S are cosine sine. Then that gives us the same equation that we just came up with, right? Because we still get AX is 2.3 cosine 30 plus 3.1 sine 30.
Why do you have just A1? We're doing A2 as well. Where?
Oh, just 8, because all I was trying to figure out is like how much of the vector is along that A1 axis. That was my first question.
So it's going to give you AX.
And that'll give me that AX value. Yeah, so now what I just solved was that this is AX, that component of RP along that A1 axis. So then I can also do the same thing, like project this vector onto here. Which means I need A2 to say RP dotted with A2 is going to give me that AY component.
A2 looks different, right? When you switch the sign to cosine. Right?
Yeah. Yeah, exactly. So A2 is going to have, like this was 30 degrees, which means that's 30 degrees off. So now we've got like a cosine 30 along the y-axis and a negative sine along that x-axis. Running out of room, just giving myself some extra space. So we'd still end up with that same like 3.1 cosine minus 2.3 sine. Two different ways. Same. We do end up with the same result both ways though. Whether you want to say like, I remember rotation matrices will stay with me forever and I'll always use them, or you can always define unit vectors are always like some combination of sines and cosines because they have to, magnitude's always 1. Cool. We're at time. All right. Wednesday, I'll send out an announcement, but I think we will not have class Wednesday. I have to figure something else out at home, but we might not have class Wednesday. I'll send an announcement to either confirm or cancel class. All right, welcome back.